Alright guys, so in order to continue working on the stoichiometry unit, alright, we're trying to use ratios, right, to make conversions between units. We're going to do a stoichiometry relay race today. You're all grouped up into teams. You have your team names up there. What you're going to do is you're going to tackle different problems, alright, together. And each of you has to go up and do a step of that problem. You can organize yourselves in a way that you need to in order to get that done. Remember that only one person can be up at the board at a time, all right? And you can help each other. If you get up there and you get stuck, go back to your group if you need to, okay? And kind of reassess the problem and where you're headed. Any questions? This lesson involved students grouping up in order to tackle a bunch of stoichiometry problems and to make unit conversions. And it's a really tough topic, so it's always nice to have them work in teams because I think that gives them more confidence to tackle them. They have someone to then bounce ideas off of.
And there's 18 water molecules.
So it would be two. It would be 18 over 2, right? No.
No. Well, there's gonna be a ratio. Right?
Yeah, I start at the mid.
Two of these molecules. 18 of them. And so if you know how much like this weighs, like say it's this much, then you know like exactly what that ratio is going to be if you know K. Yeah.
Molecules are different.
Yep, this is where we want to be. Particles. We're here, so we got to kind of go up and then. So. All right. So instead of like you said, like taking notes and maybe trying to figure it out on our own, have her come over and help. We work together as a group, and like for example, in my group, certain people knew certain things. Like Jesse knew that we had to keep like the molecule next to it the whole time. I totally forgot about that, and Jacob knows how to set it up, and I know which numbers to use and how to multiply it. So it's just like we all get to work together. We all have different things we know to kind of teach each other and learn together not the exact way, but like the right way to do it. And she was there to help too, and to make sure we all understand, we each had to go up, one at a time and write it on the board, kind of thing.
Because there isn't one.
Right, which goes. The other ratio would be. And then we have 2. But we have 2.
So 5.
Yeah, so we have to put that on the bottom, right?
Moles of air.
Oh my God.
So, and I think that's all we would need, right?
So it's 5 divided by 1.
Simply a way to count.
No, it's 5 divided by 2.
And then
2.5.
Before I always, was up at the front of the board and I would do a problem with them, and then we would kind of do another problem together, and we would just keep repeating that, and I realized that I was still kind of losing people. But by putting the teams and having them go up one by one, if you notice, like part of the game is that you couldn't just have one person in your team go up and do the whole problem. Everyone had to have a role. That changed. People were on the spot finally, and they had to know what was going on, and that I noticed a huge difference from that. It was just went from some passerbyers just kind of sitting there to, okay, I have to be involved, I have to understand because I have to participate, and that made a huge difference.
I used to really not get the relationship between AMU, which is kind of the ratios in weight to other atoms, and moles. I used to think that grams, moles, and all that sort of thing were direct ratios to each other, but really, like moles, for example, is used to count individual molecules, not necessarily individual atoms, protons, and that sort of thing. So, yeah, like that really helped. You can't just hand out worksheets and then just pass them in. What you do may be wrong. It's good to work in a group and that all gets sorted out.